We're back again, still with Learning Guide 4. Now we're looking at some formulas dealing with some exponential functions in decay or in growth. So let's just have a look here. So the first one, generally when you see a word problem that's dealing with population or light intensity, this formula is the one we use. So it's just F, which is your final answer. S is what you're starting with. G is your growth. And N is the depth or the time that you're starting with. So if we look at this first question, we're talking about British Columbia's population growth. Well, we can see that the start is 2.76 million people, and that is in 1981, so you have to make sure you realize that. Then we can look at the growth. Now the growth is the 1.022, whatever's in the bracket, but when you are asked how much is it growing by, you have to remember that it's in a percentage. So the growth in this situation, because you always start with 1 and then you add decimal 022 to get to that. So this guy gets turned, this decimal, we turn it into a percentage. So we just times by 100 and we get 2.2%. So if it asked you what is the population growth of British Columbia, we would say it's 2.2%. Okay, so you have to understand that in the formula. Okay, now it says using the graphing calculator. We're going to use Desmos, not a graphing calculator this year. So you can get that at your app store. Now, if we put the data in and we use sort of this window set here, we should have a graph that sort of looks like that. Okay, now let's answer this first question B. What is the population projected in 2021? Well, the first thing is, how many years is that? How many years? So we go 2, 2, 1. That's what we want. Subtract from the beginning, and it's 40 years. Okay, well, that's just basic math, because we have the formula there. So the population is going to be 2.76, 1.022 to the 40. And if you type that into your calculator, the answer is 6.59 million. Okay, so that's pretty straightforward. Now we want to estimate when, so the time now, we're looking for the time the population gets to 5 million. So here we set up 5 million, because that's what the final is. And we have the 2.76 million, 1.022 to the n. Now this is a little tricky because I haven't taught you log equations yet. So we'll just use our calculator and type this in. And the time is, for this one, 27.3 years. All right. How long, again, looking for the time, how long is the population double? So we have to double 2.76, so times it by 2, and we get 5.52, and then we set it up the same way. Into our calculator we can put it, and out comes 31.85 years. So those are some ways you can do that. Okay, so now we are going to look at the try one here. So when you're going to try this one, I will give you a few minutes and let you type it into your calculator and get a little sketch and see what's going on. It's a decay because this is less than 1. It's between 0 and 1. And use the calculator to determine 5%. So the answer here is 49.84%. And estimate the number of hours, 8.65 hours. Okay. Now let's look at another example here where we have to build an equation. So here, for every meter you descend into the water, 5% of the light is blocked. You use a formula to create an exponential function. Okay, so we know it's light intensity, so I just mentioned earlier we use this sort of template. Now, what do we start off with? We can start off with 100%. Just remember, you have to remember that when you're at the surface, 100% of the light is hitting you. Now, it says we are descending and we're going into the water and 5% is blocked. So that means to calculate the growth, remember you start off with 100 and you lose 5, so it's going to be a minus 5 because you're losing. So we get 95%, and then we just move it or divide by 100 or move 2 places over. So we know 0.95 goes in there to n. So there is our question, the equation for the first one to graph. So again, I look at this, I know it's between 0 and 1, so it's coming down. So I'll just draw a little sketch like that. Okay, so let's go find the answers to our questions here. So we have the first one, it says what percent of light is remaining at 6.5 meters. So we would have to set this up in this formula. So F equals 100.95, and then we put in our value of x, because we don't know, or n, doesn't really matter. And we are going to put the 6.5 into that depth, that x right there. So we type that into the calculator, and what comes out is 71.65% of light. Okay, same thing for C. We have at what depth, so we're trying to find n, or x, trying to get that guy, 50%, so 50 equals 100.95 to the x. Now again, you can do this through logs, which I'm going to show you later, but right now just use your calculator, and we get an answer of 13.5 meters. And now the last one here, now we're changing it, you're losing 7% is blocked. So your formula is going to slightly change a little bit to 93, because remember 7%, take away 100 is 93%. All right, so now we want to know how much is remaining at 5. So this 5 goes into there, and out comes 69.6%. All right. Now I'll give you a few minutes to try doing this one, so you can pause and try it and then check the answer. Okay, and those are the answers. Now we're going to move on to some half-life and doubling. So this is where it gets a little bit trickier because our new formula for half-life or doubling or even tripling, you may see tripling, is this guy right here. So I'll write it over here. F, which is your final answer. S is your starting. That's your growth. So what goes in there is a half, if it's half-life. 2 if it's doubling. 3 if it's tripling. Okay. And now it's to the T over P. Okay, so this is the thing we have to watch, the T over P, the time over the period. So just reiterate, F is the final amount, G is the growth, P is the period, and when it doubles or half-life, S is what you start with, and T is the time elapsed. So let's look at the first problem here. So we have a word problem here. So we have phosphorus used in DNA, and it has half-life of 14.3 days. So right there, that keyword half-life tells us we use this formula. F equals S G to T over P. So we know that for a fact because that word half-life. So now, what does the 14.3 mean? Is it the time or is it the period? Well, my rule of thumb is that if it's attached to the half-life, see that it's attached, they're together, it's the P. 14.3 is the P. So now I know that's going to go in there. So what do we start with? It doesn't really say. It just says radioactive phosphorus. So we know that's one chunk of phosphorus. Half-life, that's its growth. The time we do not know, so T is unknown, and the P is 14.3. Okay, so there is our formula. So now we use this formula to find out how much time when there's an eighth of that one whole thing left. So we write it out like this. 1/8 is our final. 1, that's what we started with, one piece of it. Half to T over 14.3. All right, so now I'll just quickly go through base change because we're going to get to that pretty soon. This is a pretty easy one I can show you. I'm going to change 1/8 to a half by cubing it because I know 1/8 times 1/8 times 1/8, pardon me, 1/2 times 1/2 times 1/2 is 1/8. And the reason I like that is because I have a half over here to T over 14.3. And in math, it's kind of cool that if I create the same bases, they cancel each other out. Then I work with the exponents, so 3 equals T over 14.3. Now I just do my canceling of fractions. Times that by 14.3, it's gone. And so I have to times this by 14.3. So the answer is T equals 42.9. And we are talking days. Okay, so don't forget about the units. Okay, so that